For centuries, we thought we had a pretty good handle on mapping the heavens. But what if I told you that in just the last couple of decades, that map has been completely torn up and redrawn? Today, we're going to go on a grand tour of this new cosmos, exploring the absolute frontiers of modern astrophysics. So let's dive in. So where do you even begin? Well, it all boils down to one simple question, the one that drives every single astronomer out there. What are the greatest mysteries of the cosmos that are still left to solve? And that, right there, is what this explainer is all about. We're going to explore the key areas where scientists are searching for those answers right now. All right, so here's our game plan, our map for this cosmic journey. We'll start with the guideposts that point the way, then we'll explore the universe's invisible architecture. From there, we'll join the search for life, learn how to decode violent cosmic explosions, and finally, we'll see how it all connects together in one great cosmic ecosystem. Okay, so how do they even begin to navigate this completely new cosmic territory? Well, scientists have basically set up some guideposts for us. You can think of them like these huge glowing landmarks on our new map. They point us toward the biggest questions, the absolute frontiers of what we're trying to figure out. And here they are, the key pillars of modern astrophysics. And this is some wild stuff. We're talking about everything from the invisible skeletons that hold galaxies together and the hunt for an Earth 2.0 to literally listening to black holes collide and creating a decade-long movie of the entire night sky. I mean, each one of these is a revolutionary field in itself, and we're going to touch on them as we make our way through. Let's start our journey. Our first big stop, the invisible universe. And this might come as a shock, but everything you see when you look up at the night sky, every star, every galaxy, it's just a tiny, tiny fraction of what's really there. Yeah, you heard that right. 95%. A staggering 95% of our entire universe is made up of, well, stuff we can't see. We can't touch it. We can't detect it directly. It is the ultimate cosmic mystery. And it's made up of two very, very different and very strange things. So here's how it breaks down. On one side, you have dark matter. Think of it like a cosmic glue, this extra gravity that's holding entire galaxies together so they don't just fly apart. Then on the other side, you have dark energy. It's doing the exact opposite. It's this mysterious force that's built into the fabric of space itself, and it's pushing the universe apart faster and faster. So one pulls, the other pushes. And here's the really big takeaway. It means our best theories about gravity, about energy, they're incomplete. This isn't just another puzzle. For physicists, it's a full-blown crisis. And get this. It turns out there's another invisible player shaping the cosmos. Galactic magnetic fields. Yeah, magnetism. You can picture them as the invisible skeleton of a galaxy. They guide all the gas and dust, and they're just as important as gravity when it comes to deciding where stars are born and keeping a galaxy in that beautiful spiral shape we know and love. Okay, let's shift gears. For our next stop, we're going to tackle two of the biggest questions humans have ever asked. Seriously. Where did we come from? And are we alone out here? And what's really cool is how these two giant quests are way more connected than you might think. I mean, just look at how far we've come. It was only back in 1995 that we found the very first planet outside our own solar system. Now we have the James Webb Telescope, and it's literally scanning the atmospheres of these alien worlds for things like water and methane. And the next step is already planned. We've got missions like Ariel coming up that are designed to do one thing: hunt for biosignatures, the actual chemical fingerprints of life. But here's the thing. To really understand the chances for life elsewhere, we have to look back and understand our own origin story. We have to look all the way back in time to the first billion years of the universe, a period they call the cosmic dawn. And that's what telescopes like Webb are for. They are literally time machines. They are peering back through the darkness to the moment right after the Big Bang, trying to catch a glimpse of the very first stars switching on for the first time. All right, you might want to brace yourselves for this next one. We are heading to the most violent, most extreme, most energetic places in the entire universe. I'm talking about black holes smashing into each other, stars exploding, events so powerful they literally make space-time itself ripple and shake. So how in the world do you even observe something like that? Well, this is where something called multi-messenger astrophysics comes in, and it's amazing. We don't just see these explosions with our telescopes anymore. Now we can actually feel the ripple in space-time, the gravitational wave, using detectors like LIGO. And we can even detect these tiny little ghost particles called neutrinos that come flying straight out of the heart of the explosion. It's like we've suddenly developed 3 different senses to experience the universe.
This quote it says it all, doesn't it? For the very first time, we can hear what's happening. By catching those gravitational waves, we are literally listening to the sound of 2 black holes spiraling into each other and merging. It is absolutely mind-bending to even think about.
And that brings us perfectly to this idea of the dynamic universe. The thinking here is, why are we just taking snapshots of the sky? Let's make a movie instead. And that's exactly what new observatories like the Vera C. Rubin are going to do. They're going to scan the entire sky every few nights for 10 years straight, creating a film. Why? Because they're trying to catch things that just flash or explode for a split second. Because it's in those fleeting, blink-and-you-miss-it moments that we might just discover some brand new physics. Okay, for our final stop on this journey, we're going to zoom all the way out. We're going to see the biggest picture possible. Because it turns out, everything we've been talking about, none of it happens in a vacuum. It's all part of one single, giant, interconnected cosmic system. What we're realizing now is that galaxies aren't these lonely islands floating in space. No, they're more like hubs in a massive cosmic web made of gas. It's called the baryon cycle, and you can think of it like galaxies are breathing. They're constantly inhaling fresh gas from this web to build new stars, and then they're exhaling the old, processed material back out. It's the universe's ultimate recycling program. And it means a galaxy's entire life story is tied to its neighborhood in ways we're just now starting to understand. And that interconnectedness, it goes all the way down to solar systems too. There's this amazing field called planetary archaeology, where we compare our home, our solar system, to the thousands of others we've now discovered. And you know what we're finding out? We might be the weird ones. So many other systems have these things called hot Jupiters, these huge gas giants orbiting way closer to their star than Mercury is to our sun. It proves that planets move around, they migrate. And when you dig into the archaeology of these other systems, you have to start wondering, is our calm, stable solar system just a total cosmic fluke? So, from the 95% of the universe that's invisible, all the way to this great cosmic web connecting everything, our map of the cosmos has been totally, fundamentally redrawn. But this isn't the end of the story, not even close. It's really just the beginning of the real exploration. And that leaves us with the biggest question of all. With all these new maps and new tools, what completely new, completely unknown territory are we going to discover next?